Hey guys, thank you guys for coming out to lecture tonight. So today we're going to be talking about microservices. I hope you guys were able to finish the homework and you guys had a little more restful week since we weren't covering anything too technical last week. But yeah, let's get to announcements. So the full project skeleton has been released. If you cloned the project skeleton, just pull again. This includes the Go code, the dependency, the Docker files, and there is a Docker compose file that is currently empty. We will talk more about this later, but anything that you need to fill out for the project until the end of the semester has already been released on the project skeleton. So yeah, feel free to dig around. We've released an assignment that's just like a few really basic written questions on microservices, so you'll be able to answer that after this lecture. So that is the first checkpoint, just a written assignment due Friday. It's 3 questions. We're not expecting entire essays, just maybe 2 to 4 sentences on each one, just based on effort really. AWS Educate accounts, please sign up. So the deadline to actually receive points for signing up was, I believe, yesterday. Was it today or last night? I'm not sure, but the deadline is over, but it's still necessary to complete the later parts of this course. So if you're, I know there's a few people that haven't signed up yet. If you're having difficulty, just reach out. I think we've been able to resolve a few issues on Piazza. Yeah, so last time, so just a refresher, we did cover Docker and SQL. So we're going to be using Docker a lot in this class. You're going to be learning how to use those Docker commands, and you'll be implementing some SQL queries to interact with databases. Hope you guys found Shane's resume workshop useful. So thank you, Shane, for leading that. And I hope you guys found the LinkedIn workshop by Ismail very useful as well. And we've run into some issues because the slides and recording is proprietary. We can't really share them publicly, unfortunately, but I hope that the people that came by to lecture that day did find it useful. So today we're going to be talking about different architectures for software development. So monolithic architecture is one. We're going to talk about the benefits and drawbacks. We're also going to be talking about microservices, which is a little more relevant to this course. We're going to talk about the benefits, drawbacks, and discuss whether or not they're better than monoliths, or if there's different scenarios where one might be better than the other. So let's actually define what a monolithic architecture is. This is a diagram. So you can see that the monolithic architecture is essentially where you have all the code and all the business logic and everything packaged into one instance. So that means your entire app is just kind of like all the different logic parts, and every subpart, every subservice is packaged into one instance, and that's how you run it. So the key idea is the entire application is deployed as a whole. All the parts are part of a single cohesive whole that when you run the single part, it runs everything else. So you run the application and it's ready to deploy. So some examples would be the Golang web server. So we didn't, everything in the Golang web server that you guys wrote was self-contained. It did not depend on any other services. It just, it took in data and it spit it out. The 601A Hog project and maybe pretty much all the class projects you do are monolithic architectures in the sense that, you run it and everything is running ready to deploy. You don't have to run multiple parts of the project just to have it running. Cal Central is actually a monolithic architecture, and oddly enough, I don't know if many of you know, but the source code for Cal Central is actually on GitHub, publicly, it's public and you can view it. So it's pretty interesting. I highly recommend you check it out just to kind of dig around. So the benefits of a monolithic architecture where you have all your parts clumped together is that it's really simple to develop and it's really easy to get running, because when you're coming in from nothing, all you have to do is toss some logic into your program and it's ready to run. It's all your code in one place. And it's simple to do end-to-end testing, because all you have to do is, well, let me describe what end-to-end testing is. It's when you do a full suite test of all of the functions of your project. So let's say you're trying to make a web application that has like a browser interface. All you have to do is, kind of fuzz test everything, where you try different combinations. So all you have to do is run the actual code and kind of, pick at it. And it's simple to deploy. All you really have to do is package and build a program, and you can run multiple instances with Kubernetes, which we'll be talking about later on. But essentially, if you want to make your program fault tolerant, you run multiple instances so that in case one goes down, the others can still serve the purpose of the program. And that is few. Let's see. There's a few logistical questions in the chat, which I'll answer in just a bit. So if other students can kind of pitch in, that'd be great. I think we're not tight on time today. So the drawbacks of a monolithic architecture is complexity. They initially are very useful when you're starting out with an app, but they get very, very complex because the size of the code base only gets larger, and they become very difficult to maintain. Meaning that when you have someone trying to edit a specific part of the program or a specific part of the code, you have to make sure that it doesn't affect anything else, which if everything is kind of clumped together may be an issue. And updating requires a full restart. So if you have an update that you roll out for a single part of your program, all of your instances need to be restarted. And that's kind of a problem because then you can have server, company-wide outages. Dependency issues. Different parts of your programs might need to use different versions of the same software. So when and the thing is, you can generally only have one type of dependency unless you really dig into like the very like detailed like functionalities of like your dependency management system. It's a lot, and it's honestly not worth it, especially when you have a large code base. And a single bug can take down the entire program, because remember that all of the services and all of the different blocks of logic that you have within your program are actually compounded together, and if the code actually like has like a runtime error or something like that, or a seg fault, it'll take down the entire instance, which can be an issue. And if any of you have worked at any large company or any company with a large code base that uses a monolithic architecture, it'll probably look something like that. There tends to be a lot of spaghetti code when you have a single product that's running on a monolithic architecture, because you just have too many like functionalities clumped together, and it doesn't look pretty. So let's think about microservice architectures. So key idea, you break down your product by functionality. So we'll go into how this relates to the project in a little bit, but maybe you want to have something like you want to break it into like, let's say you're trying to set up a payment system. You can have something that handles the sign-in, handles the actual transaction between, your service and the consumer. And then you have another service that, handles the transaction between you and an actual bank. So you can kind of divide up your entire app into different parts that don't depend on each other, and then you can run them individually. So, and each program has its own set of dependencies, so that you don't have to worry about dependency management, because if two different microservices in your product need two different versions of the same dependency, they're both self-contained, so you don't have to worry about that. So some examples are Google. Generally, when you try to do a Google search, it probably goes to like 6 layers of microservices. Don't quote me on that, but there's a lot of microservices that go on at Google. Facebook also uses microservices. You can imagine that when you're trying to search for people on Facebook and add them as a friend, it doesn't interact with your messenger, at least by that much. Or when you're trying to like read a news feed, or something like that, then it doesn't interact directly with like adding or removing friends. And bear chat. So we're going to be using microservices, and we'll get into more detail on that in just a sec. So let's talk about the microservice architecture. What are its benefits? So what makes it better than monolithic architectures where everything is kind of together rather than distributed? It's easier to unit test because the services are smaller. So if you want to test a very specific part of your code, you can do it independently of any other functionality. So if I wanted to test the microservice that handles my authorization, I don't have to think about, like bank transactions or anything. I just have to figure out, why can't they user sign in or something like that. Easier to grade scope test as well. Yes, that is very accurate. It's much easier for the core staff to test microservices as well. Yeah. So when you're trying to unit test on a monolithic architecture, it becomes very difficult because sometimes there's weird like connections between different parts of the code. And yeah, microservices are way easier to deploy because you deploy each part of your program independently. So if you have a product that does multiple different things, all you have to do is create a microservice for each functional logic block and then run it independently. And then you can, in case one has an error, it doesn't bring down everything else. It's easier to collaborate on because when you have like a company like as large as Google, or if you guys decide like, you want to break down your product into multiple different things at like your future startups that you found or something, You can just divide your product into microservices and assign a team to each microservice. That way it's easier to collaborate on. You get smaller teams working on more concrete tasks, and that eventually makes it easy, that lets you release products faster, because you always know where the error is and which team needs to step up their game. Fault isolation is probably one of the bigger like advantages of microservice architectures, because if you'll notice that if you have a bug in one microservice in your project, which you guys will be developing, it won't affect the others. So if you have one service go down, it's not going to take down the others. It's just going to go down by itself, and it's going to start itself back up. So it's really important, especially when you have a code base spanning tens of thousands of lines, and you don't want them to be clumped up together and make it hard to figure out where an error came from. Another thing is easier to pivot tech stacks for different functionalities. So although everything in the project is going to be written in Golang, if you wanted to rewrite some aspect of the project in a different language, you guys will be completely able to do that, and it would run exactly the same because everything is containerized. So you can actually just swap out languages in microservice pretty much whenever you want. I mean, it's not recommended to do it very often, but it helps you get rid of tech debt. If you figure out, if you're using some technology that was from 10 years ago and it's been updated a million times, or there's a new, better technology, it's really easy to just swap it out and redevelop that specific, function of your code, rather than the entire code base needing to be rewritten. So this is what a microservice architecture would look like. You have a different task, and sometimes microservices might point to other microservices before eventually ending up at the database to do some kind of read or write. So your user interface would be something like your web browser, and then the web browser would send some requests to your backend, and the backend is comprised of multiple different microservices. But does anyone have any questions on this diagram or anything about microservices or the idea of microservices so far? Just are all databases independent? Yeah, the databases are also independent because each one runs in its own container. And if you have let's say these 3 different microservices doing different things, then the databases are also going to be different, and they're not going to depend on each other. So you can actually think about it wouldn't be like a technically correct term, but it helps to think about databases kind of like a microservice, because they run as a server and they're very isolated. How does this relate to Docker? Okay, this is a really good question. Docker lets you build, so if you recall from the previous lectures, Docker lets you build containers. So it lets you package your code and all of its dependencies into a container. Now, what you do with Docker is you can create a container for each microservice. So you can think about it as every microservice has its own container. And it's amazing because Docker doesn't require any other dependencies besides what's in the container or what you tell it or what you give it. And that's why it's perfect to deploy microservices. So you take your program, you deploy it independently, you take another part of it, you deploy it independently with a Docker container, and then it just runs. Will we be following a microservice architecture for the project? Yes, you will be. And if you poke around the code, you'll see why it's so much easier. But yeah, that's a homework question, so I'm not going to give you too much detail on that. Can microservices communicate with each other at all, or does that defeat the purpose? Or does that defeat the purpose of a microservice? Microservices can communicate with each other. You'll see in the next slide with the drawbacks that if you have too many entanglements with different microservices, if you have like 5 layers and they all kind of point to one another, that's one drawback. But yes, they can communicate with each other. So you can have multiple different layers of microservices that kind of like go down deeper until you hit a database. I guess one example would be if you're trying to sign in to your banking, or let's say you're signing into Amazon and then you create a purchase. What an example would be Microsoft having a microservice where the first microservice you hit is the authorization service that checks that you're authorized to make the purchase, that you're properly signed in. That'll do some kind of database read or write. Then that microservice forwards your request to the actual Amazon, like the Amazon marketplace, and it says, okay, we're going to we're going to take some transaction and we're going to give this person their product. And then that microservice might point to another microservice that does the actual banking, where they take your credit card or your debit card information and they actually send a request to the bank, and eventually that propagates back up and lets you complete your purchase. So that's a very good question. Microservices communicate all the time, especially at much larger companies. Now, yeah, so microservices are not they're very, very amazing. I honestly like implementing microservice architectures, but they're not like a catch-all solution to everything. When we distribute the logic of our program into different functionalities and different microservices, we create a distributed system, and that becomes very complex in its own way, because you can have microservices not directly depending on the like microservice might not depend necessarily on whether another microservice is up or down, but when you're forwarding a request, like you're breaking down a HTTP request into different steps, and each step is at a microservice, it can become complex. Because what happens in the Amazon purchase example, what happens when like you try to deduct, you already gave the person, like what happens if you try to give the person that ordered something the product, right? You say, okay, your purchase has been successful, but the time between the purchase and the banking, between the time of the purchase and actually calling the bank and asking them to give you the money from this person's account, what if there's an error? And then you might point it to another microservice which handles errors, and it becomes very complex. You can depend on the functionalities, but you don't have to depend on whether they're running or not. End-to-end testing is a little more complex, because when you're unit testing, you always know where the error came from. It's the specific microservice that you're testing. But end-to-end can become very difficult, because once you're trying to do a full suite test, if you have a very complex microservice architecture, you don't always know which microservice always gets the request. You might have different microservices getting requests from other microservices depending on an if statement or something, or a condition, and that can become more complex. But that can be circumvented by using adequate logging mechanisms. So you always log where the requests are going into some database, but more on that later. Yeah, and more containers means more memory overhead. So if we try to package our entire product into one monolithic architecture and one container, we just have that container running. Let's say 5 of those containers running. But if we want to, let's say, break down into 5 different parts, we want each and every single microservice. So all 5 microservices need to be fault tolerant, and they need to be robust. So that means we need to allocate 5, let's say 5 different containers to each different microservices. So we end up with, in this protocol, we end up with 5 times the amount of containers that we actually need. So there is a drawback, because if you think about it, if you're trying to have, let's say, 5 computers do the computing versus 25 to do the exact same thing, depending on how you set that up, it can be very memory expensive. Latency is something that's very, very worthy of discussion, but it's very minimal. When you're communicating within an app, it's completely instant, because the program is set up in the that computer's memory. And if you want to, let's say, if you had like your transaction all in one program, it'll be basically instant, because you're just calling a function, versus a container which has to probably be networked. So everything, like when you're communicating with containers, generally they'll be over a network, whether it's on the same server or a different server. And if you have multiple, let's say like 2 or 3 layers, it won't be much. But once you have multiple layers of microservices that do different things for like a single request, it can become very time consuming. So there is a time overhead here, and that's something to keep in mind. So this is where we decide whether microservices are good or bad, or whether monoliths are good or bad. And if I were to be completely honest with you, there is actually no right or wrong answer. companies tend to pivot. Companies have more recently pivoted to microservices recently, but there's still a lot of companies, especially like very enterprisey companies and government companies, that tend to rely on monolithic architectures, and they both work fine. Lots of companies, they're doing perfectly fine, and they're not moving to microservices. They just update their code base, and it's all working for them. I found that more of like I think the startup sphere is more like microservice oriented. So monoliths are very good if you have a small team, a simple application, and you want to launch something fast. So if you guys are planning to make a startup, please do not start off with microservices unless you have a lot of microservice expertise on your team, because just planning out what services communicate to which databases, or even how to divvy up what microservices do what, can take up a lot of time. And if you're trying to get a quick launch, or you're trying to get funding, it's very time consuming, and it's really not worth it. But yeah, but what I've seen a lot is that a lot of people might start off with a monolith microservice, but as their applications and products become more complex and they begin hiring more people, they tend to pivot toward microservices and do a refactor of their code base. So for microservices, if you have a complex and scalable application, meaning that you need to handle lots of requests really, really fast, and you know that you have the audience that already does that, that's when you do that. When you're starting a new company or something and you have a very simple product, you're probably not going to have 1 million users within the first month unless it's like extremely extravagant, which I hope happens at some point for you guys. But generally, what happens is that you start off with a very small product and then you scale it up eventually. And microservices require microservice expertise. When you're writing a monolith, all you have to do is have a single Git repo with all your code on it. Microservices tend to be a little more complex in their containerization, into how they communicate, and it requires a lot of expertise and experience in this area. So I recommend you guys be wary. In terms of this project, I'd say the project is a large, I guess, you can think about it as the commitment of a 61B project, but since you guys are in pairs, or if you decide to be alone, I think you guys will be fine. But yeah, so I'm going to be talking about the project microservice architecture. So we have the authorization microservice. So when we have our social media platform, every user must sign up before, they have to register for the platform before being able to use it. So we need to actually handle all the different authorization procedures. So when we sign up for an account, when we sign into an account, and when we want to log out, those are the big three. We're also going to be handling email verification. So you guys will be, we decided that the actual logic for the email verification is out of, it's out of scope. So we have the code that sends the email written out for you, but you guys will be in charge of writing the SQL query and everything that determines whether a user is verified or not. So I think that'll still be exciting. We have a friends microservices. So you can't have a social media platform without some kind of following or some kinds of friends list. So you guys will be able to add, remove friends, and check mutual friends. So when you go to someone's profile, you'll see whether or not that you have a friend in common with them. There's a posts microservice, which lets you, add, delete, and view posts. So you'll be able to create your own posts, you'll be able to delete your own posts, and you'll be able to view all the posts of every other user that's used this. So think about it as like a global kind of Twitter. And the profiles microservice will let you create and update and view other people's profiles as your own. So you get to create your profile when you sign in or sign up. And then if you decide along the way you want to update it, you can do that, and you can view anyone else's profile. So this is a very short lecture. Do you guys have any questions so far? Because I'm going to get more into administrivia. So technical questions only for now. Yeah, so there's a question about the security of the stored login information. Yeah, you guys will be learning how to hash passwords and things like that. I think I'm not sure what we're still messing around with what topics we're going to be teaching when, but you guys will learn on how to handle user passwords and how to properly hash and salt them and what all that means. You'll also learn about the security vulnerabilities associated with cookies and web browsers. And let's see. So yeah, you guys will be in charge of learning the actual microservice security. Yeah, if that's what you're asking. And is RESTful API synonymous to microservice? RESTful API refers to pretty much I think it was representational state transfer. So I think RESTful API is synonymous to HTTP API. So I would say that HTTP API or RESTful APIs would be like it would be a subset of microservices, because like microservices would they can listen to RESTful API requests, if that makes sense. So like each microservice has like an actual API that it responds to. So they're kind of different, but it's not whether they're synonymous. The question is whether, like, does one use the other? Enigma, I haven't heard about it. I'm not sure what exactly is that a 61B project? Okay, yeah, then I got the right idea. But yeah, we'll be using a library called bcrypt to actually hash our passwords. And every time we sign in, we take the password that the signed in user sent. We're gonna hash it and compare it to the hash of the actual one in the database. If you guys aren't familiar with hashing, don't worry about it. We're gonna probably cover it in the next 1 or 2 lectures. But yeah, security is very important, but unfortunately we can't go into as much depth as we would like, because just in the spirit of time, we want you guys to focus on specifically the projects and kind of like getting your hands dirty. If you want to learn more about security, I highly recommend 161. It's my favorite class to date, probably the most fun I've had in a class. Like the entire class is just learning how to hack stuff. Like you're given a C, like for the first third, it's like you get to hack different C programs based on like different vulnerabilities. And then I think for like the final project, they give you like a website that you hack and try to like sign in as other users. It's pretty cool. Highly recommend you guys check it out if you are very interested in security. Cool. So I guess that's it. And I'm gonna go into a little bit of administrivia, but if you guys want to like ask more technical questions, yeah, feel free to just keep asking. Let me go back to the beginning. So one thing that's really, really important is that this class will begin to start feeling like a 3-unit class starting next week, because next week is when you guys will be assigned the actual checkpoint where you guys have to code and write code. We're still figuring out how we're going to be auto-grading them and how we're going to make everything compile and everything. But you guys will be responsible for a certain level of coding. And we allowed you guys to have partners, and we've taken out a bunch of like the actual like annoying bits of the program so that you guys can focus on just the logic. But you can expect to spend just on coding maybe like 6 hours a week, not 6 hours, it's like 5 to 6 hours. Yeah, and we're trying to scale up our office hours. I'm trying to clear out like all day Fridays. I'm not sure how that's going to work out, but we will see. Well, it's still a topic of discussion. But yeah, TLDR, you guys are going to be having a lot more fun, but you're also going to be having a lot more not fun, because debugging can be a pain sometimes. But during office hours, we'll help you cover that. But yeah, is there any questions regarding the project? You guys can I can actually pull up the link and send the link for those of you that haven't had a chance to look at it yet. Let's see here. But if you guys want to take a look, here we go. Yeah. So unit tests, I believe Cyrus will be covering. Unit tests will just be like a Python script that kind of tests each and every endpoint. So you guys don't have to worry about that. But I highly recommend that you guys learn how to do that. I think that's we're a little too tight on time to like spend a lecture on it. But let's see, we'll try to do that. I think that we can take like one of the miscellaneous topics lectures and then make it a debugging lecture, because when the core staff and I were putting this project together, it was like knowing how and where to debug was a lifesaver. Yeah, you guys will not be graded on tests, but we will show you how to write tests. Since these are, they're not going to be as annoying as like the tests you write in 61B. They're going to be very straightforward because these are all like network requests, and you guys probably can use a Python library to do that. So yeah, actually, quick question. Would you guys prefer that you write your own test in Python, or would you want to like do a continuation of Go? Because I know a lot of people like have taken 61A. Yeah, but so, yeah, it makes more sense to use Go, right? Because we're already, yeah, Go has, and the thing is, Go has its own like native testing library, which I think is cool. It also has a native networking library. So you guys, okay. Thanks for the feedback. We'll try to get. Oh yeah, the concepts are the same. They're like Go, both like Go unit tests and Python unit tests would send a network request. And since the structure is the same for network request, the program that you write won't actually know whether it's Python or Go. It'll just know that it received a request and it needs to give something back. And yeah, so same concept, but I think we'll stick to Go because it seems like you guys are dying to get digging with more Go. So let's see. I'm just trying to cover all the logistics for the project. So yeah, expect to work maybe 5 to 6 hours. If you guys feel stuck, come to office hours. We have access to the staff solution and things like that. I believe you guys should have received an email for your partners. Did you guys get that? Let me